Hey, good morning, everybody. This is Mr. Ainsworth. We're going to get into section 3 here again. We're going to translate sine and cosine waves. We're actually going to graph them this time, basically in the reverse process of part 1. We're going to be given the equation. We're going to graph the function by analyzing its amplitude, its period, its b value, and its shift. Okay? So let's get into part 2. But before we do, let's do a couple problems like we did last time here. Let's find an equation of a cosine function. All right, with amplitude of 7. All right, period equals to 3. If that's the case, then that means that b is equal to, let me see, b is equal to 2 pi divided by 3. All right, b is 2 pi divided by 3. And the shift right here, the shift is 3 units to the left. Okay, that'd be a negative 3. And then 4 units up, that'd be positive 4. So that's h and that's k. How do you write a cosine function that describes all that? Well, we got y minus k in general equals a times cosine of b times x minus h. You have to know your general form first. You just substitute your values in. So you have y minus 4 is equal to a, which is given to be 7, amplitude of 7, times cosine of b, which is your 2/3 pi, times x minus h, which is a negative 3. All right, so x minus a negative 3 would be x plus 3. On the next one here, basically what we did last time is we took a look at the graph here and we analyzed all this information here. So the very first thing we do is we draw the wave axis. Okay, so let's go ahead and do that. It runs right through the middle of the wave. Looks like right about here. So there's my wave axis at y equals 2. Okay, so I've got a wave axis of 2 at y equals 2, excuse me. Let me see, we've got 1, 2, 2, 4, 6, 8. It's 8 high, and then, let me see, 2, yeah, that's right. And then 2, 4, it's down at negative 4. So from 2 to 8, this is my amplitude right here. Amplitude is equal to a minus 2 is 6. Amplitude is 6. Let me just record that here. And let's see, I need to figure out the period here, the period length. Let me see, you're at negative 4 here, okay, and positive 4 here. The period is between these two values, so the period is length right there. There's period is 8, so my period is 8. That means b is equal to 2 pi divided by p, or 8, or pi fourths. And the only thing I need to do is figure out a shift. Okay, and then let's do it for both sine and cosine. So let's talk sine first. Sine starts here, goes up and back down. So the question is, how do you get from the origin to this point? This is for sine. So you got to shift left 4 and up 2. So for sine, it's negative 4 comma 2. That's my shift for sine. So if I want to write that curve, I got y minus 2 is equal to a, which is 6, times sine of b, which is pi fourths, times x minus h, which is negative 4. So I'm going to go plus 4 here. Now, cosine doesn't start there. Cosine starts with an amplitude of 6. It starts at 6, which is right here. Okay, so cosine starts there at 6 because it has an amplitude of 6. But then how do you get to this maximum? Because it's been translated, so you got to go left and then up. So the question is, how many left, how many up? And you go left 2 and then up 2. So for cosine, it's left 2, up 2, or negative 2 comma 2, where h is negative 2 and k is 2. So you have y minus 2 now is equal to 6 times the cosine of pi fourths times the quantity x minus a negative 2, which is x plus 2. And that's your shift, or your equation in terms of cosine. All right, those are the skills from last section. So now what we want to do this section is reverse the process. I give you the function, you come up with a graph for one period. Okay, so let's go ahead and let's take a look at that and let's get some experience. Again, this is part 2. Here we go. All right, remember, you got your general forms here. You got your second general form here in terms of cosine. And you got all of your definitions in here. My first example here is just a basic one here. And let's analyze. Well, let's go ahead and do it for all of these here. We got a lot to do. Woohoo! All right. Let's go ahead and analyze all these functions to get a lot of experience. So the amplitude, we got A here, B, we got H, and we got K. You have to know your general form. So amplitude is 2. Let me better put this in blue, it'd be a little bit easier to see in my notes. So amplitude is 2. B is 5. So if B is 5, that means P is equal to 2 pi divided by B, or 2 pi fifths. Okay, so 2/5 pi is my period. My phase shift is H comma K. Phase shift translation, same thing. So this is H comma K. Here it's 2 comma 3. So 2 comma 3. My wave axis is always y equals K, and then that tells you that it's got to be y equals 3. Don't put down just 3. It's not a real number. It's an equation. It's a horizontal line. So the wave axis is always y equals K in general. Okay. All this right here is this defined up here on the left. So these are your definitions on the left. All right, and I'm applying it on the right in example 1. Now the amplitude is always the absolute value of A. Keep that in mind. Now on this one here, my A is -3. So I got to take the absolute value of it because the amplitude is the distance, and distance is always positive. All the negative does is reflection across the x-axis. We'll talk about that later. So we got -3, absolute value -3, which is 3. The period, let me see, B is 1/2 right here, so that's 2 pi divided by B, or 2 pi divided by 1/2, which is 4 pi. So I got a period of 4 pi. The phase shift is H comma K. In this case, it's 4 comma -4. This is y minus a -4, so there's K is -4 there. So 4 comma -4 is my shift, and the wave axis is y equals K again, so I have y equals -4. So as soon as you figure out your shift, you know your wave axis by looking at the function itself. Okay, and once again, we're going to go through all of these examples here together, just to get a lot of experience. By the way, a question of this type is going to be on the test, so this is a good practice. You have to be able to analyze a function and determine all 4 pieces of information here. Okay, the next one here, this is the same thing. If I add pi to both sides, is y plus pi here, okay, equals 8 times the cosine of 3 pi, which is b here, times quantity x plus 2 pi. All right, so my amplitude is 8, so 8 here. B is 3 pi, so I have 2 pi divided by 3 pi, so my period is 2/3. You just take B and divide it into 2 pi to figure out your period. Okay, and the phase shift is H comma K. This is positive, so x minus the -2 pi is equivalent here, so my H is actually negative, so -2 pi, and then my K, y plus pi is the same thing as y minus a -pi, so -pi is my K value. My wave axis is y equals K, where K right here is -pi. So you notice that your values don't have to be just whole numbers or integers. It could be in terms of pi as well. Kind of weird, but that's could be the case. On example 4, we got amplitude of absolute value of -pi, which is pi. Remember, amplitude is distance, and therefore it has to be positive, so you got to take the absolute value of it. B is 2 divided by pi, so I take 2 pi divided by 2 over pi, multiply by the reciprocal, and the 2's cancel, and I get pi times pi, or pi squared. That's a fun value. So there you go. Phase shift right here, my K. This is x minus a -8, so H is -8, and then if I subtract 3 on both sides, K is -3. Excuse me, no, K is 3, excuse me, K is positive. So I've got -8 comma 3, so -8 comma 3 for my, whoops, I've got to write it up here, -8 comma 3 for my phase shift, or my translation, and then since K is 3, I get y equals 3 as my wave axis. Okay. Here the amplitude is 28. And let me see, period here for this one, b is 3 here. The period for a tangent is pi, so it's not 2 pi divided by b, it's just in general pi divided by b. So for this one you take the period of tangent, which is pi divided by b. So in this case it would be pi thirds. And the translation would be 1 comma negative 1. H is 1. You look here for h and look here for k. Y minus a negative 1, where k is negative 1. And then the wave axis, there is no wave axis here, not for tangent. This is a tangent function. Kind of snuck that in there. Okay, and so there's none here. Not for a tangent function. Not for tangent, only for sine and cosine. Okay? All right. So let's go ahead and get some experience here, and let's graph one period only. Okay, take notice of that right there. And the first thing you do on all of these is go ahead and determine the piece of information here, write them down first, and then go ahead and graph the results. All right? All right, so here we go. A is 5. Okay. B equals 2. That means P is equal to 2 pi divided by 2, or pi. Remember, period is 2 pi divided by B for a sine wave. All right, for sine and cosine only. Sine and cosine only. All right, and also, my shift is 0, 3. 0, 3 because h is 0 here in this case. And my wave axis, WA for wave axis, is y equals k, where k is 3. So the very first thing I do is I draw the wave axis. That's the very first thing. I'm going to put that in red. Y equals 3. Label that. Y equals 3, wave axis. Very first thing. And then I know my amplitude is 5. Excuse me, my amplitude... Yeah, okay. My amplitude is 5. So I'm going to be up 5. I'm going to have to go up here. So 1, 2, 3, 4. Oops, it's way up here now. I should have shifted this down a little bit lower, but that's okay. That's right, I'm just going to continue down 5. 1, 2, 3, 4, 5. So my wave is going to oscillate between these two horizontal lines that I'm drawing. Again, the amplitude right here is 5. Amplitude here is 5. So it's going to bounce back and forth between these two lines. The question is, where does it start? Okay, and we got a sine wave here. Now the sine wave usually starts at the origin, but it's been translated up 3 units. That's what 0, 3 means. This is your shift. So because the sine wave starts here at the origin, typically, when it's not translated, we go from the origin up 3 units, and now the sine wave starts here. Okay? Because you translate up 3 units. That's what 0, 3 means. Now what you do is you go over pi radians. The period is pi. So from here I go over 4 units, or a multiple of 4. I could go over 8 if I want to expand it. I'm just going to go make it easy. I'm going to go over 4. I'm going to label that pi because I want to graph one period only. Okay, one period. Always go over 4 units, or 8 if you want to expand it. Now the sine wave, generally, you got to remember this now. This is from our experience. You go over the period length and divide it up into 4 equal parts, and it goes up. Okay, it goes up and then back down and then back up again. That's sine. That's what sine does. So from here, since we're starting at 0, 3, you got to go over 1/4 of the period and go all the way up, and then back down to the wave, and then go over 3 parts all the way down, and then back up again. So what you do is you plot your points, just like you would normally. You plot this point, this point, this point, this point, this point. You plot 5 points. You do that over here as well. You start here now, though, not at the origin, but up 3 units because it's been translated. You go over to the right and then up, back down to the wave axis, and then over 3 parts, down, and then back up to the wave axis, and then sketch. Okay, and that's 1 period only. 1 period only. And then what you could do is if you wanted more than 1 period, if you want to go to 0 to 2 pi, just repeat these 5 points and then continue and draw or graph as many periods as you want. And that's the experience that you need to get. All right, so let's do it a few more times and let's gain that experience. So here we go. Let's try another one here. On this one here, we've got, I'm going to add 2 here. So y plus 2 is equal to, is equal to 2 cosine of 1/2 x. Now, where b is 1/2, a is 2, and h is 0. There's nothing being subtracted here, and k is -2. So let's write all that down. We've got a equals to the amplitude. B is 1/2. Period is equal to 2 pi divided by 1/2, which is 4 pi. We've got a shift being 0, -2. And then we've got wave axis at -2. Okay, so it's the wave axis. That's the very first thing you do is you analyze the function, you write down everything. You're going to do that for me when we practice. And then after you do that, then you scale your axes and you go for it. Alright, so let's go ahead and go for it, okay? Let's draw the wave axis first. I'm going to put that in red at -2. Alright, and then let me see. Our amplitude is 2, so we go up 2, down 2. So my wave has to oscillate in between these 2 dotted lines. Why? Because the amplitude is 2. It goes up 2, down 2. Okay, the amplitude tells you the distance above the wave axis, so it oscillates in between here. The question is, where does it start? Now we're talking about a cosine curve. And a cosine curve with an amplitude of 2 would normally start right here at height 2. Normally starts here with amplitude of 2. But this thing's been translated. Now 0, -2 means that it translates 2 units down. Okay, so now it starts here. So it starts right here, and that's a max. Remember on the cosine curve, you start at the amplitude and it goes down and it hits a low point, a minimum, and then back up. This is for cosine now. So you always start at a max. So it starts here, and then what you have to do is you have to go over, you have to use the period now, 4 pi. So I'm going to shift over 4 units. So 1, 2, 3, 4. So in between here and here is going to be 1 period. So I'm going to label this 4 pi, and I'm going to plot my points. And it's going to go down to the wave axis, all right, and then go over 2 parts all the way down to a minimum, and then it goes right back to the wave axis, and then back up to a high point. So it looks like this. It's got to be curved. And you want to be plotting 5 points again, these points right here. Again, plot 5 points. Plot 5 points, and I'm going to be looking for those when we practice. Now that's 1 period only. Notice 1 period only here. And if you wanted to repeat that, so you can maybe go out to 8 pi, you can just repeat those points, and then it oscillates in between this curve, or in between these 2 horizontal lines. Because that's what amplitude means. It goes up 2 and then down 2, and up 2 and then down 2, from the wave axis, that is. In this case, the wave axis is not the x-axis, it's y equals -2. Okay, this is the x-axis here, and this is the y-axis. All right, let's do one last time. Get some more experience here. We have, oops, that's not A. A is 6, B is pi fourths. So A is 6, amplitude is 6. And let's see here, amplitude is 6, B is pi fourths, H, K, they're negative, X, this is X minus -2, and this right here is y minus a negative 3, so both h and k are negative. B, or period, is 2 pi divided by pi fourths. Alright, 2 pi times the reciprocal, alright, will give us a period of 8. So my period is 8. And let's see, this is a sine curve. Let me see, the translation is negative 2 comma negative 3, so my shift, negative 2 comma negative 3, and my wave axis, y equals k, or y equals negative 3. Okay, so I need to start with the wave axis at negative 3. I draw that first. Alright, so there's my wave axis. Y equals negative 3, wave axis. Then I use my amplitude. I'm going to go up 6 from here. So 1, 2, 3, 4, 5, 6, right here. And then down 6, 3, 4, 5, 6. No. Got to make my graph bigger next time, don't I? Okay, again, my amplitude is right here, a equals 6. Amplitude right here, a equals 6. So my wave is going to be oscillating big time in between these two horizontal dotted lines. Okay, with an amplitude of 6. Question is, where do you start? Now, sine curve usually starts at the origin. Here's the origin. But it's been translated 2 units left and 3 units up. Oh, excuse me, 2 units left, 3 units down. So from here, I got to go left 2 units and down 3. Alright, and now I start here. This is where I start. Okay, at negative 2 comma negative 3 from the origin. Now what I do is I use my period. My period is length 8. So on the wave axis here, let me switch to blue. I'll graph this in blue. I'm going to start here. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. I'm going to end here. Okay, and now I'm going to divide it up into 4 equal parts. And 8 divided by 4 is 2, so I'm going to divide it up into 4 equal parts this way. So I'm going to start here, and then I go over one part up to the max, back down to the wave axis, all the way down, or over another part, go all the way down to my minimum, and back up to the wave axis. A sine wave always does that. It goes up and then back down and then back up again. And then you draw a curve. Alright, let me clean that up a little bit. There we go. Alright, and so it looks kind of like this. And again, you're plotting 5 points here. You're plotting this point, this point, this point, this point, and this point. And again, we're going to get some practice in class. I got a cool software program to help us with that. And I'll have you guys practice this up on the front main board. But in the meantime, you try these problems here. Check solutions. Okay, online. That's your responsibility. All right, and then if you have any questions, see me in intervention and speak up. Okay, I'll see you then. Work your best. Make yourself proud. Do your homework. And I'll see you tomorrow.